take a look at integration using the power rule. Let's go ahead and make a tab, label it power rule. Right, so the integration of f of x dx is equal to capital F of x, just in case you need to know this notation. This is a listening check. Go ahead and title this page power rule. So looking at an example, integrate x cubed dx. So in derivatives, we would subtract 1 to the power. So in integration, because it's the opposite, we're going to add 1 to the power, and then you divide the function by the new power. So you add 1 to the power and you divide the function by that new power. Then after that, you add c to the whole thing. Don't forget that. Sometimes I forget that one. Add c to the whole thing. And number 3, check your answer by taking the derivative. It only takes a second, especially on these easy ones. Alright, so let's add 1 to the power and divide by the new power. So 3 plus 1 is 4. Divide by the new power, which is now 4. And then add c to the whole thing. And then now let's check our answer. So let's say we were taking the derivative of x to the 4th over 4. So dy dx is bring the 4 down, so that's 4x subtract 1 is cubed over 4. And c is just a number, so that goes to 0. Alright, then simplify that. The 4's cancel, you get x cubed. And that's exactly what we started off with. So integration, differentiation, opposite. Let's take a look at another example. If you have a constant at this step 0 here, take the constant out of the integral. Right, so I forgot to write that the first time, but take the constant out of the integral. So let's take it out. So it's going to be 8 integral of x to the 6th power dx. Add 1 to the power, then divide by the new power. So that's 8 x to the 7 over 7. Then add c to the whole thing, and then check your answer. I'm not going to check it for everyone, but you can check it. Alright, let's take a look at another one. Let's say you have a bigger function. It's still the same process. It's like taking the integral of the individual functions. So go ahead and break them all up. This is a listening check. Put a box around example 3. Take any constants out, because that's I guess it's step 0. Take any constants out. So I'm going to rewrite it as 2 integral of x dx minus integral of x squared dx plus, take the 6 out, 6 integral x cubed dx. And now add 1 to the power and divide. So the first one has a 2 outside, and then add 1 to the power, so it's going to be x2 over 2. Minus, that's going to be x3 over 3. You're just adding 1 to the power and divide it, plus 6, and then x4 over 4. And then don't forget to add that plus c to the whole thing. Let's simplify this. The 2's are going to cancel out, leaving x squared on the first one, minus x cubed over cubed, plus 3x to the 4th over 2, because 6 over 4 simplifies to 3 halves, plus c. Let's take a look at one more example. We can write 1 over square root of x as x to the power of negative 1 half dx. And then it's the same thing. Add 1 to the power, then divide it by that new power, plus c. And rewrite it back in terms of square roots. 1 divided by a half is 2. And if you don't believe me, you can just keep, change, flip. So it's going to be 2 radical x plus c. Right, so again, I'm just going to check this one just to make sure. So 2 radical x would be 2x to the 1 half. So the derivative of that would be subtract 1 half. So 1 half times 2 would be 1, and then x to the 1 half, which is the same as 1 over radical x. And that's pretty much it. So that's a power rule, really quick, really easy. It's just the opposite of derivative. So let's practice.